Hi, in this video we are going to study some data compression algorithms. We have introduced how to represent images and video or audios in the previous slides. So as we all know, if we using binary to represent images or video, it's going to occupy a huge amount of storage. So in this case, we have to provide some data compression technology to reduce the storage size. Basically, we have two types of data compression, the lossless data compression and the lossy data compression. So the lossless data compression means that the data can be retrieved without any loss of the original information. The lossy compression, it means that some information may be lost in the process of compression. So the lossless compression is based on statistics or specific data structure. So it's common in text in certain application domains, such as medical images. Especially the information is so important that you cannot lose any of them. So in this case, we're going to use the lossless data compression. For the lossy compression, it means that some of the information we can discard because it's not that important and sometimes it's insensitive. So this is common for audio, images, and video. Of course, we don't want to use the lossy compression to compress our bank account. If your balance is changed from 10,000 to 1,000, that's definitely not acceptable. So first, let's look at the lossless data compression. There are two examples. The first one is called the keyword encoding. The second one is called run-length encoding. So the keyword encoding means that if we have some frequently used words, we can use some symbol to replace the word. For example, in this table, we have these words, and these words are frequently used in the text. So in this case, we can change to these symbols because the symbol only have one character, so it is going to save some space. Note that the characters used to encode cannot be part of the original text. Otherwise, you cannot retrieve the original information. So here shows an example of the keyword encoding. So the first paragraph, you have some keywords, which is in green. And for the second paragraph, you're going to replace the keywords by using the symbols according to the previous table. So there are totally 349 characters in the original paragraph, including spaces and punctuations. But the encoded paragraph only contains 314 characters, resulting in a saving of 35 characters. So in this case, we can calculate the compression ratio. It is approximately 0.9. We can use the size of the file after the data compression divided by the size of the original file to get the data compression ratio. The second technique is called run-length encoding. If we have 7 A's, we don't really need to represent all the A characters. So this could be encoded as asterisk A7, meaning that we have 7 A's here. For example, for this string, we can use the run-length encoding to compress as this one. So this means we have 5 N's, and then we have 9 X, and then have 3 C's, and then we have 6 H. So in the second example, the original text contains 51 characters, and the encoded string only contains 35 characters, so giving us the compression ratio of 0.68. But we never see any text showing this kind of pattern. So this run-length encoding technique is mostly used in the images. So for the audio compression, MP3 is an important technique. It employs both the lossy and the lossless compression. It will first analyze the frequency spread and discard information that cannot be heard by the humans, because human ears can only hear a range of the frequency. If the frequency is out of the range of the human's ear, then it is not necessary to hold this information. And then the bit stream is compressed using a form of Huffman encoding to achieve additional compression. So the compression ratio for MP3 file is usually 1/10 to 1/12. The image compression is really lossy by discarding information not sensitive to our eyes. Because for a true color RGB color, we can have more than 16 million different colors, and for most of the time we cannot distinguish some similar colors. For example, these two colors looks quite same, but their value is actually different. So in this case, we can change them into the same value so that we can use the run length encoding technique to compress the color. For example, we have a matrix of different values, and in this case, we can use the run length encoding, replacing all the nearby values using the 34. And then we can use 25/34 to replace the original matrix. So in this case, we only need two numbers to represent its original 25 different numbers. The method and the technique we use to compress the video is called codec. It is used to shrink the size of a movie to allow it to be played on computer or over the network. So almost all of the video codec use lossy compression to minimize the huge amount of data associated with the video. For example, the videos we made to show you the course materials is also being compressed by using some software. Some other technologies used in the video compression, like temporal compression and the spatial compression. Temporal compression is a technique based on differences between consecutive frames. If most of an image in 2 frames hasn't changed, so why should we waste the space to duplicate all the similar information? So in this case, we don't need to store the same information in the second frame. The spatial compression is a technique based on removing redundant information within a frame. So this problem is essentially the same as the faced when compression still images.